Alright, hi. Today we'll be talking about convergent and divergent series, which is one of the many pathways you can go on from pre-calculus and math that actually deal with working with series of numbers and going, okay, is it going to be convergent or divergent? Now, convergent means they converge on at one number. Okay, divergent means that they go on forever and they expand and you really can't add them. So that's usually when you're dealing with infinites and stuff and just working with that. And there's going to be two tests we're going to worry about first. Now, first off, right here, we're going to come back to this in a second. I'm going to talk about the ratio test. Now, the ratio test is you're going to use it to find if two series are actually going to be well, you can use it to find if any series is actually going to be convergible by just using the ratio test. And the ratio test does this, okay? So let's start off with first our actual series. All right, the first thing we do for a ratio test is we find a sub n. Okay, so we actually find the explicit formula, and so that's going to be really easy when to work with this. All right, so if you set this up as n equals 1, and this one is n equals 2, this one is n equals 3, and this one as n equals 4. Okay, if you notice the top of the actual fraction is just n. So just n is going to be the top. Now the bottom is going to be 2 to the whatever power, so it's 2 to the n. So that one's pretty simple. Now what you're going to do is you're going to also find the explicit formula for n plus 1. Okay? And so what this is going to be is the top will actually be n plus 1. Okay, and you just basically add 1 to each of the n's. Okay, so this works right here. All right, now in the ratio test, what you're going to do is you are going to divide this by this, and if we get an r less than 1, we can actually say that this is convergent. If r is greater than 1, then we would say it's divergent. If r equals 1, we can't say anything because this test doesn't help with that, okay? And then we would jump into something like the comparison test. Okay, so we start doing some division, so it's going to be n plus 1. And we're also going to do this as the limit of n approaches infinity. Okay, so the limit as n approaches infinity. Okay, so on the top, pretty simple. Okay, so it's going to be n divided by 2 to the n plus 1. Okay, and then we're going to divide that by the original formula that we came up with, which was n divided by 2 to the n. Okay. Okay. Now what we're going to do is we're going to notice, oh, it's a fraction divided by a fraction, so let's flip it and multiply it by the reciprocal. So 2n over n. Okay, remember this no longer exists. Okay, so the n and the n plus 1 don't do anything, but the 2n plus 1 and the 2n, you can actually separate this part by saying that is 2 to the n times 2 to the first. Okay? Alright, so that will actually cancel out, so this is actually really good because we don't want that to be infinity. Okay? And so what I'm left with, it's a little bit tricky, I'm going to be left with the limit, and just pretend I'm writing limit as n approaches infinity in front of each one. So on top I would actually have n plus 1 over 2n. Okay? Because I still have that 2. Because remember, even though I got rid of the 2 to the n, I still have a 2 to the first down there. Okay? Now, if I divide everything by 2n, so I'm going to get 1/2 plus 1 divided by 2n. Okay, if you notice as n approaches infinity, this part is actually going to approach 0, okay, because the fraction's getting smaller and smaller. And so this actually, the common ratio is actually going to be 1/2. So this series is actually convergent. Ta-da! I know it's a little bit tricky and just working with this stuff, but if you just treat it like you're just trying to solve it and simplify it down to just a number, and then you do the limit as n approaches infinity, it makes your job a whole lot easier. I did get a little bit messy in this actual picture. Okay. All right, now let me see. Okay, I did want to talk about the comparison test. Now the comparison test, and we're going to use this set of series for reference for the comparison test. Basically, the comparison test is you have a convergent series if your series is less than a known convergent series, which would be this one and this one. Okay, and it's divergent if it's greater than a known divergent series, which would be these three right here. Okay. All right, and the first one is just your basic common ratio formula, which is r is less than 1, and then this one is when it's r is greater than 1. Divergent is just your simple arithmetic series, so that one's pretty simple. Divergent is the sum of all the fractions as you go up to n, so that's actually kind of interesting. You think that one would be convergent, and then convergent would be 1 over 2 to the p plus 1 over 3 to the p plus 1 over 4 to the p, and it just works its way up. Okay, so remember, once again, the comparison test is a little bit different, but it's actually a little bit more exact because all we have to do is test if it's less than or greater than a certain type. Okay. All right, so now if I take a look at this actual series, I'm going to find out that the common term or the general formula is going to be 4 divided by parentheses 2n plus 3. And how are you going to arrive to these actual formulas is by looking at what the n is. So remember, this number up here is n equals, okay, as you go across, and then try to find the formula that matches all the stuff on the bottom. Okay, so just as it works, and you want to pretend you start at n equals 1 and you want to be able to get it. So what I do is I just deal with the top part separate from the bottom part. So if you notice, each one's 4. Okay, so obviously this top part's going to be 4, and then the bottom is going to be 5, 7, 9, 11. How do I represent that as an actual function? I'm just going to go 2n plus 3. Okay. All right, so the first one I'm going to look at is actually the divergent series. I'm going to take a look at this one right here. It's a sum of all the fractions. Okay. All right, and since they're not increasing exponentially, that's something that's going to give us a hint as where to go. This is actually going to be greater than 1 over n, which is what, if you notice over here, that was actually the general formula for it. Okay, well, guess what? That's greater than that. So this is actually, we've proven beyond a doubt that this is divergent. Okay, so what you're going to do is you're going to find the common formula first, and then compare it with the common formula for these actual series over here. And here's this one, this one. This common formula, you're probably going to have n times d. Okay, and then here's the common formula for this one. Okay, all right, if you can prove it's less than that, you should be good to go as you work across. Okay, all right, so that's it for talking about convergent divergent series. If you have any questions, please feel free to ask me. This is definitely a new concept. I will talk to you guys later. Bye.